Hi. Uh, we are going to continue with buoyancy this session. So students, I hope that you have revised and you have gone through my last video about buoyancy, and we've understood the derivation of the Archimedes principle, which basically says that the buoyant force is equal to the weight of the liquid displaced by a body. Right. We'll have a quick look at that derivation once again, just to refresh, and then we will go ahead with yeah. So what is that? So buoyancy is equal to LBHI into rho g, right? What is LBHI? It's a volume of the liquid displaced. HI is the height of the body below water or below the liquid, right? So LBHI is a volume of the liquid which has been displaced, because that much volume of body has pushed aside that much volume of liquid. So that much liquid has been displaced by the body, and if you multiply that volume with the density of liquid and g, we are getting the weight of the liquid displaced by that body. So the buoyant force is equal to weight of the liquid displaced by the body, and that is nothing but Archimedes principle. Before getting into that, I want to just tell you that this video is coming from Navayug Study, which is a student channel which has video recordings and materials for middle school and high school students, focusing on physics, chemistry, and mathematics. And you can get in touch with us in following ways. So our website is http://navayugstudy.wordpress.com, and so this is the way you can visit our website. And it has got all the videos in a very structured fashion, the study materials. There are ways of submitting questions. There are ways of requesting for Google Plus one-on-one web video sessions if you have to clear doubts with us. All those are there. Please have a look at navayugstudy.wordpress.com website. You can get in touch with us on email as Navayug. This is navayug.study@gmail.com. That's our email ID. And we also have a Google Plus community, which is in fact a private community composed of parents, students, and the faculty. A Google Plus community. You can get the details of this Google Plus community and the link to join it in this website. Please go and look at our website and make use of the email ID if you want to get in touch with us. Ideas, if you have any doubts on any of these videos, there are ways of clearing it. Please go to this website and check it out. Okay, thank you. Now we'll go back to the presentation. So before we start with the presentation, I actually in fact wanted to show you just go through the discussion we had on the derivation of Archimedes principle, right? Or derivation of the buoyant force. I would always advise students to go to derivation and understand it, because that gives the concept. Don't try to study in by heart volume into the density of liquid into G is buoyancy. No, that's not the right way to study physics, right? You have to know the derivation so that you really know the concept. Yes, the student is saying that the physicist has to know what he is learning. Absolutely, I agree, right? So please go through this derivation very well. If you don't understand the derivation, please submit a question. We'll clear your doubt. If you want to have a Google Plus session, please go ahead and request for a Google Plus session. We can specifically discuss your doubts right wherever you have. All right. So as you've seen this derivation, ultimately we derived that the buoyant force is equal to the weight of the, not exactly, I mean in this case the liquid is water, right? So in this case the liquid is water, but otherwise you say it's a weight of the liquid displaced by the body, right? is what the buoyant force is going to be. All right, we'll do some few problems which will actually give you clarity on what I explained, right? Okay, now, so we've seen that the factors which determines the buoyant force is directly proportional to the volume of the liquid displaced and directly proportional to the density of the liquid displaced, right? And of course, why? Because you say it's weight of the liquid displaced. Weight is nothing but volume of the liquid into the density of the liquid into g, right? So that's what it is. So um, so what is buoyant force? As you've seen, buoyant force is equal to, just a moment. Okay, so okay, let's just remove this. Okay, so what is buoyant force? Buoyant force is equal to volume volume of the liquid displaced, which means that much volume of the body under the liquid, that much of the volume has been displaced by that body, because matter occupies space, right? Well, not into the weight. Volume of the liquid displaced into the density of the liquid into G, right? So volume of the liquid displaced into density of the liquid into density of the liquid into G. In fact, if you look at this product, it's nothing but the weight of the liquid displaced, right? Volume into density is nothing but volume into density into acceleration to gravity always gives volume into density gives the mass, right? Volume into density always gives a mass, because density is mass per unit volume. You multiply volume into density gives a mass of the liquid displaced. If I multiply that with G, then it gives the weight, right? Mass, as I told you, mass into acceleration to gravity always gives a weight of a matter, right? So here you're saying volume of the liquid displaced into density of the liquid into G. That inside, in fact, gets a weight of the liquid displaced, and that is what the buoyant force is, right? So that is why you can say, and if you look at the ratio and proportions in mathematics that you learned, so now you're saying that force, so I can say the buoyant force is directly proportional to the volume, because if the volume increases, volume of the liquid displaced increases, the buoyant forces will increase. If the density of the liquid increases, then also buoyant force will increase, right? So that is basically what it is. I hope you understood that, you know, volume of the liquid displaced into density of the liquid into G. So that is, so it is from this, I'm making the statement that the buoyancy is directly proportional to the volume of the liquid displaced, and is also directly proportional to the density of the liquid. Okay, fine. So when a body is floating in a liquid, then the weight of the whole body is vertically acting downwards will be equal to the weight of the liquid displaced by immersed part of the body acting vertically upwards, right? That is what it's going to be. So you have an equilibrium. That's why the body is not going down. So you have the weight of the body going down, right? And you have the buoyant force, which is equal to the weight of the liquid displaced acting up, right? So if I go back and draw a diagram, before this, I think I should draw white. Okay, so let me draw some container, and this container has got liquid, and here's a body. Fill this up. Okay, and here's a body just floating, and this is a liquid. So now what are the forces acting on the body? So you have the gravitational force, which is nothing but the weight of the body acting downwards because of gravity, and then at the same time you have the buoyant force, which is acting upwards, the B, right, which is a buoyant force, and that buoyant force is equal to the weight of the liquid displaced by this much part of the body, which is below the water, right? And so, now the body is neither going down neither going up, which means both the forces are in equilibrium. What is equilibrium? Forces, that is what is called, forces are in equilibrium. Equilibrium. Which means that the weight is equal to the buoyant force. Both the forces are cancelling each other, and since they are cancelling each other, they're in equilibrium, and so there's no net resultant force acting on that body. The resultant force is, what is the resultant force? So you have seen that, right? So if two forces are acting on a body in opposite directions, the resultant force is the difference between the two forces, right? So here, what is the difference? W minus B, and that is equal to 0 because these two forces are equal to each other, and so there is no resultant force. The resultant force is 0. Resultant force is 0 Newton, and since the resultant force is 0 Newton, the body is neither going up or going down. So that is why it is called equilibrium. Always we say the forces are acting on equilibrium means that forces are cancelling each other, and because of that the net force on the body is 0. That is what is equilibrium. Okay, so you learn this in detail when you learn Newton's law. Don't worry about that, and we will be dealing with that sometime this year. So I think forces are in equilibrium. I think the course concept is clear, and this is what is happening when a body is floating on in liquid, where the weight is acting downwards and the buoyancy acting upwards, and both of them are equal to each other, and because of that there is no net force acting on the body, and so the body just stands still. Any questions, students? Anything which is not clear? I think the students have to concentrate in the class. The student is asking what is W and what is B. I had explained this in the beginning, right? So the weight, W is the weight of the body acting downwards because of gravity, and B is the buoyant force which is acting upwards, right? So right now the situation is that the weight and the buoyant force are equal to each other, and so there's no net force acting on the body, and so because of that you can say it's on equilibrium. Please concentrate in the class. It's very, very important that when the class is going on, your full focus and concentration is there, because otherwise you're spending an hour going through this video and you're getting nothing out of it, right? So please be constant. So when you're sitting in front of the class, we see that you're not sleepy and you are not having your concentration and all that, because then you're wasting your time. So you should never do that. You should focus and be with 120% concentration when you're attending the class. All right? Okay, fine. So let us go back and continue. Okay, so now what is Archimedes principle? So Archimedes is the person who wrote a law about it.
When he went, he discovered this concept of buoyancy in a bathtub.
Absolutely. So the students are saying that the concept of this buoyancy he discovered when he got into a bathtub. That is true, right? So he was really pondering about this whole notion of buoyancy, and then the story says that he got into a bathtub and he found that the level of the water in the bathtub was going up.
A little more lighter.
Yes, he felt a little more lighter, and he also found that the level of the water in the bathtub is going up because his body was displacing water, right? Because matter occupies space, and because of that, and then he found that there's some relationship between that feeling of lightness to the amount of water being displaced by its body, right? So so and he was, it seems that he was so excited then and he was, and he's a scientist, so scientists are so passionate about what they think about and what they research. He was so passionate that it seems he forgot that he had undressed himself, and he was like not putting any dress, and he just started running around, shouting that I discovered something. So that these are all stories. We don't know whether that's true or not, but these are stories which you can read in books about Archimedes, right? And but ultimately what he proved is that the weight of the liquid or the weight of the fluid displaced. You should understand that buoyancy is not a concept restricted to liquids. It's also there in gases. It is the same principle by which a hot air balloon is able to float in air. It's because of the buoyancy. Because what is happening is that the density of air inside the balloon, because it's hot air, the density of air inside the balloon is less than the density of air outside, the atmospheric air, right, which is not hot. So because of that difference in density, what is happening is that the balloon is displacing the cold air outside, and that cold air is actually giving a buoyant force upwards, right? So we'll discuss that in detail. Don't worry, I'm going to discuss about hot air balloon, why it is able to float, but you should understand that even that is because of buoyancy, right? So so the concept of buoyant force and buoyancy is not restricted to liquid. It is also there in gases. So both gases and liquids exhibit this concept of buoyancy, right? So that is why it says weight of the liquid of the equal to weight of liquid, not weight of the fluid displaced. As I told you, fluid includes both liquids and gases, right? So this law of buoyancy applies to fluids, which could be liquids or which could be gases. I hope it's clear. Students, is it clear?
Yes.
Okay, fine. So when a body is partially or wholly immersed in a liquid or gas, that is basically in fluid, it experiences an upward buoyant force which is equal to the weight of the fluid displaced by the immersed part of the body. Okay, now this is what is the Archimedes principle. I hope that students, any questions on Archimedes principle, something which is not clear?
No.
Okay, fine. So now let us go and do a problem. So I have a container. I think before doing the problem, I want to show you a video which actually kind of explains Archimedes principle. So let us just go to the. So here you can see that there is a weighing. There is a weighing machine, right? And there is a potato, and there is a spring balance, right? And there is a jug of water. So that is what you have, and there is actually a beaker. You can see there's a beaker with water, right? Now let us look at this experiment. Now this experiment is trying to prove that the buoyant force is equal to the weight of the liquid displaced, right? Now what he has done is right now is he has filled the he's going to fill the water till the this overflow. So how this beaker is shaped is as follows, right? So so this beaker is like this. So you have this beaker like that, right? And there is a overflow pipe here, right? There's an overflow pipe, and if and when and there is liquid up, he fills the liquid up to the brim. So it's not overflowing now, but if there is any displacement of water, it will start overflowing. So as soon as I put a body inside this, right, As soon as a body put a body, this body is going to displace water.
Yeah,
Why?
because any matter occupies space.
Any matter occupies space. Absolutely. Student is saying any matter occupies space. So as soon as I dip a body inside this, what is going to happen is that it's going to displace water, and that water starts flowing down, right?
Because the water level increases.
A water level increase, and that water will flow down, and that water is being collected somewhere else, right? Now let us see. So I just want to explain about this beaker and how this beaker looks like, right? That's why I just came here. So let us go ahead with the video, right? Now let us see what this scientist is going to do. So he has got a beaker of water and this beaker with the overflow pipe, and there's a weighing machine. Now he's going to fill the water till the brim, as I showed you in the figure which I drew, right? You can see he's filled the water all the way to the brim. Yeah, so now the water is there till the brim, and okay, so he has emptied that beaker where the overflow water could be collected, right? So all those is fine, right? And he has got water up to the brim now. And now what he's doing is he is using a spring balance, and the spring balance is weighing, and it is finding the weight. Okay, it's 125 grams. Now what he's going to do is he's immersing, and as he immerses, what is happening? As he immerses that whatever body, which is, I think it's a potato, it is displacing water, right? It is displacing water, and you can see now what has happened to the weight. I don't know, I think he didn't show it properly. So he should have waited a little bit. Anyway, let us see once again. So when he immersed, you can see that in the spring balance, the weight it showed reduced by almost 100. See, you can see it came down to almost 25 grams or 10 grams or something, I think, right? So it is showing 125. It actually came down to 15 or something, right?
Because its weight became lighter.
Yeah, why? Because the buoyant force was acting upwards. So weight was acting downwards, the buoyant force was acting upwards, and net force is what comes to the spring balance. The net force is what? The weight minus buoyant force. So ultimately the net force which is acting down reduced as much as the buoyant force, right? So what was it? Let us go back here, right? Let me draw and explain that to you. So you basically had so this was a spring balance, right? And then there was a body hanging, and the spring balance initially showed something here, right? So this is a scale of spring balance. It showed it here. Say it was 125 grams, right? Then what happened is, as soon as he immersed, so now what is this? This is equal to the weight, right, which was acting downwards. Now when he immersed that in a beaker of water, of course what happened is the body displaced the liquid, right? So he immersed in water, then this body, that is a potato, had displaced water, right? And because of that, there is a weight of the displaced water acting as buoyant force upwards. So now what the net force which is acting on a spring balance is? W minus B, right? The net force which is acting, student, the net force which is acting on the spring balance will be what? W minus B. Why? Because W is acting downwards, B is acting upwards. The net force which is acting, N, is W minus V, which is far less than W. And so what happens is now the weight balance shows the new scale, right, which is here, which shows the weight is far lesser, and say assume it showed 25 grams, right? So now 125 gram force, right, minus 25 gram force is the net force acting. N is equal to 125 gram force minus 25 gram force. Agreed,
Yeah.
students?
Yeah.
Agreed. So which basically means net force which acted, oh sorry, not like that. I got it a little wrong. So what is the net force which is acting now? So the net force which is acting is 25 gram force. So 25 gram force is net force, and that net force is equal to 125 gram force minus B. Right? See, net force N is equal to W minus B. Right? What is N? N is what is measured. The net force is what is measured. Once I immerse the body into water, the weighing scale is measuring 25 grams. So the net force which is acting on the weighing scale is 25 gram force, right? So 25 grams force is equal to 125 gram force minus P. I just replaced the equation with the right values. Weight is 125 gram force. When we weighed it without immersing in water, the weight was 125 gram force. After we immersed, the scale is showing 25, which means the net force now is 25 gram force. So net force is equal to 25 gram force minus the net force is equal to 25 gram force is equal to the weight minus buoyant force. So buoyant force is going to be what? Buoyant force is equal to 125 gram force.
Plus.
No, this goes this way.
Minus.
Minus 25 gram force, which is equal to 100 gram force. So 100 gram force is a buoyancy, and that will be equal to what?
Displacement use.
No, will be equal to, if we are able to measure the volume which is displaced, volume into density of water into G.
No. Transferring reduce that.
Yeah, the transferring, that overflow of water, right? Yeah, so that is what he's going to do now. I'm just trying to explain why this scale showed a lower value, right? Why after the body was immersed, why the scale showed a lower value. That is what I was trying to explain through it. Why it showed a lower value is because now it's not only the weight, the buoyant force is acting upward. So the net force which is acting is weight minus buoyant force. That is why it showed and that difference is going to show the buoyant force which is acting, right? Let's go back to the video. Is it clear?
Yeah.
So now you saw that as soon as it was immersed, the force which showed was far lesser, and now he is going to find. So if you look at what is collected in this beaker is the volume of the water which was displaced. At the point when the immersing was done, the amount of volume of the water displaced is what is collected here. If I multiply that with density of water and G, what will I get? Students, if I measure this volume of water and I multiply that with density of water and G, what am I going to get?
Get the
Buoyant force. Precisely, the student is saying I will get the buoyant force which acted on this body when it was immersed. Right? Absolutely right. So that is what he's going to calculate now. So what he's going to do is he's simply going to put that above the spring balance. That will give the weight. Right? He poured all that water and he's measuring the weight of that water. That is equal to the buoyant force. Right? So he just compute. Now what he is finding using this weighing scale is the weight of the water which was displaced by potato when it was immersed.
So you find the buoyant force of the volume of water which is displaced.
No, not buoyant force of the volume of the water.
That's the volume of water displaced.
Yeah, so now when he pushed that onto the weighing, so student is saying, is it not the volume of the water displaced? Yes. As soon as he pours that onto a weighing scale, what is he getting? He is getting the weight of the water
Weight of the water displaced.
displaced. Yes, the student gave the answer. He is getting the weight of the water displaced. Right? So now what this weighing scale is showing is the weight of the water displaced by the potato when it was immersed in water. And that is equal to the buoyant force. Excellent. Right? That is equal to the buoyant force. And you can see that is showing 100. Don't you see that?
So 100 is his buoyant force.
100 is the buoyant force. And that is correct. Because as soon as we immerse, what you saw the weighing scale? 25. Before he immersed, the weighing scale showed 125. After immersing, it showed 25. And so difference between 125 and 25 is 100. And that is the buoyant force. And that is what it shows here. Right? So Everything is right now. So this experiment is exactly showing that the buoyant force is equal to the weight of the weight of the fluid displaced by the body when it is immersed. Is it clear?
Yeah.
Any questions on this experiment? I think your textbook also explains this experiment. You can go through this, but I want to really show this experiment happening so that you are clear, right? So this is a wonderful video which actually shows the experiment happening. All right, so now let us go back and do a problem using Archimedes principle. So now I have a beaker. And in this beaker I have got water, right? I've got water, and I've got a block of wood. Let us see that I draw a block of wood. Okay. So this is a oops. This is a block of wood which I have, right? And it is floating in water. Why is it floating in water? Students, I explained this. Why is wood floating in water? What is the reason? Because
If the weight of the
because it's to do with the density. Because the density of wood is
the density of wood is
okay, fine. All right. So there is that revision has not happened. It's okay, fine. So it is able to float because the density of wood is less than density of water, right? That's why. Okay. Anyway, leave it. So now the wood is floating in water, right? And I am giving the following. Length of the wooden block is 50 centimeter. Breadth of the wooden block is equal to 40 centimeter. Height of the wooden block is equal to 40 centimeter. Density of wood is equal to density of wood. Density of wood is equal to 500 kilogram per meter cube. Density of water is equal to 1000 kilogram per meter cube. Okay, this many things are given. What is asked is what is the height of the portion of the wooden block which is immersed in water. What is this h? It is the height of the portion of the wooden block which is immersed in water. What is that? That is what you have to find. How do you do this? So see, first thing is that wood block is floating in water. That is given, right? Which means that the wood block is neither going down nor going up. It is just staying on the floating in water. Absolutely. Student is saying equilibrium. Absolutely. There is equilibrium. Excellent. Wonderful answer. Right? There is equilibrium, which means that the equilibrium between what all? Equilibrium.
the weight and the buoyancy.
Absolutely. Weight is equal to the buoyancy. So you got an equation here. Now, what is the weight of the wooden block? Weight is equal to volume.
Volume into density.
Volume, that is only mass, right? Volume into density of wood.
Density of wood and density of water.
No. Weight of the wooden block is volume into density into
Volume into density into
volume into
LBH.
No. So volume into density gives what? Volume into density gives
Density gives mass.
mass. Mass into what gives weight?
Mass. Mass into what?
Acceleration due to gravity, right? Mass into acceleration due to gravity always gives weight for any matter. For any matter, if the mass is known, just multiply the acceleration due to gravity, you get weight. So the weight is volume of the wooden block into density of wooden block into G, which is nothing but LBH into raw wood into G. What is LBH? LBH is, we have to convert everything into meters, right? Because you want to do everything in SI unit. So what is 50 centimeters? How many meters? Student, 50 centimeters is how many meters?
50 centimeters. Five.
What should I do to get it in meters?
Is equal to 5.
What should I do to get meters? You have to divide it by 100 because 1 meter is equal to 100 centimeters, right? So it is 0.5 into 0.4 into 0.4, right? That's the volume. 0.5 into 0.4 into 0.4 is the volume. Into density of wood is 500
kg per meter.
into acceleration to gravity is 9.81, right? So 0.5 into 0.4 is so 20. So this is 0.2. So it's 0.08 into 500 into 9.81, which is nothing but, so 500 into this thing will be 40. 40 into 9.81 will be 81 into 4. 4, 2, 3, 39, 40. Okay, so it is 392 Newton is a weight. 392 Newton is the weight of the wooden block, right? Now, what is a buoyant force? Buoyant force is the weight of the liquid displaced. What is the weight of the weight of the fluid displaced here? Weight of the fluid displaced is, what is the weight of the fluid displaced? Is equal to the volume of the fluid displaced, let's call it VD, volume of the fluid displaced into
Density of the liquid.
the density of the liquid, which is here density of water, into
Acceleration due to gravity.
acceleration derivative. Excellent. So student, I did not tell it, students told the answer, right? Now, what is the volume of the liquid displaced here? It is equal to L LBHI, and this is HI here, right? So LBHI is L is 50 point, sorry, not points, 50, 0.5, because I won't do it in meters. 0.5 into 0.4 into H, right, which is what you have to find, into 1000 into 9.81, right? So which is, and so since it's equilibrium, we can, what is this? 0.5 into 0.4 is 0.2. 0.2 into 1000 is 200. 200 into 9.81 is I think 1962, right? So 196200. So okay, so I think it will be 392 is equal to 0.2. Okay, it's 200 okay, so it's 1962 into H. So H is equal to 392 divided by 1962, which I think you should divide and find. That gives you in meters, right? So this is the answer. Please divide it yourself and find it out. And this answer you get it in which unit? In the answer will be in what unit? Meter. That many meters. So this you find it yourself. I don't want to do the division. I know that all of you know how to do the division. So I hope you understood. We just looked at the equilibrium. Weight is equal to buoyancy, and you came out with the linear equation. Yeah, tell me.
What's VD? VD thing?
VD is the volume of the liquid displaced.
Oh.
VD is volume of the liquid displaced, which is 0.5 into 0.4 into H,
Yeah.
right?
Yeah.
That is what it is. So the question was, what is VD? And I am saying that VD is nothing but the volume of the liquid displaced. So this gives a simple problem where we have found what is the depth of the the block of wood which is immersed in water, right, by using the equilibrium. A simple problem where we have used the buoyancy Archimedes principle to find what is the depth of the wooden block which is immersed, right? Any questions? Is it clear? Okay. So that's about that problem. Let's go ahead. Now, assume I take the same problem. I want you to do it yourself, right? This problem I want you to do it yourself. This is a homework for you. Okay? Will you do the homework, students?
Yes.
Okay, fine. So now I am having a container. I have a container. Again, I have got a wooden block. I got a wooden block. Here is a wooden block. But this time it is floating in kerosene. Okay? It is floating in kerosene. So this is wooden block length. So this wooden block, length of wooden block is 50 centimeter, breadth is 40 centimeter, height is 40 centimeter. The density of wood is just the same as last problem, 500 kilogram per meter cube, right? But it is floating in kerosene. So I want you now to find. So what should you find? You have to find the density of kerosene for sure, right? So now this is kerosene. I want you to find HI here. What is the HI? Right? If you want the density of kerosene, I'll give you that. Density of kerosene. Let us just find it from the internet. I forgot to note that down. Density of kerosene. Okay. Density of kerosene is 780 kilogram per meter cube. Okay. So density rho kerosene is equal to 780 kilogram per meter cube. I want you to find what is HI. Homework.
50. Please allow me to copy as I have to do it for my.
Sure, sure. So student wants to copy this so that he can do. I'm giving a couple of minutes to copy. Now, the other question which I have, the other question, is that, so first is you have to find HI. This is question number A. Question number B is, if instead of block of wood, if it was block of iron, huh? Will it float? Will it float? Of course, for this you have to find the density of iron, which I want to leave it to you. You can find it from internet or from books that you have, right? You can find the density of iron. But the question is that, the question B is, if the block, instead of block of wood, it was a block of iron, will it float? You should understand, if anything has to float, the weight of the body should be equal to the buoyant force. What is the maximum buoyant force a body can have? If the whole body is immersed in the liquid. If the whole body is immersed in the liquid, that's a maximum, because that's the maximum amount of volume it would have displaced. So the question number B, what you have to check is, if the whole block of iron with the same dimensions immerses in body inside the kerosene, right? The buoyant force it would have had, will it be equal to its weight, or will it be less than weight? If it is less than weight, then definitely the body will go down. It cannot float, right? That is the concept. So the hint here is, so hint for this question, hint is, if the if instead of block of wood, if it was block of iron, will it float? Will it float? That's the question, right? So hint is, if the whole block of iron immerses in kerosene, that is maximum buoyant force. Will that buoyant force be equal to weight, W? If it is not equal, if it is less than weight, then the body will just simply dip and fall into the liquid, right? Because the weight is more than the buoyant force. But if the buoyant force is at least equal to the weight, then it will still float. Of course, it will float with the whole body inside the liquid. But if the buoyant force is less than the weight, then the body will simply fall down, right? It will just simply fall down and it will settle at the bottom of the vessel. So what will happen if it is iron is something you want to check. Okay, I can give you the density of iron. Just a moment. Just give me one moment. I'll also find the density of iron. Right, the density of iron. Density of iron is 6,980 kilograms per meter cube. What did I do? So here the density of iron, rho iron, is equal to 6,980 kilogram per meter cube. Okay. So I hope you understood the question. Any questions you have? Any doubts you have for this question, students?
Now that we have the hint, there is no doubts.
Yeah, all right. So the students are saying that with the hint they will be able to answer this question. If you have any doubts, please get in touch with me. All right. Okay, so let us go ahead. Let me just now the next point which I want to discuss with you is how is a ship floating? Ship is so massive. It may weigh hundreds of tons, and over and above it will carry goods in it, which will be again hundreds of tons. And it's made of steel, very dense, highly dense material whose density is far higher than the density of water. Then how is it able to float? The, yes, but how? Typically, I have told you if the density of the body is more than density of the fluid, then it cannot float, right? So here, if you look at ship is made of steel, which density is around 7,000 kilogram per meter cube, whereas the density of water is 1,000 kilogram per meter cube, which is more. Density of steel is 7,000 kilogram per meter cube. Density of water is 1,000 kilogram per meter cube. So which is more? Density of water is more. Density of, listen to what I say, right? Listen. When the teacher is saying no, one time the teacher says you should be able to grasp. That shows you are in full concentration in the class, right? So that is the way you should see, because you should be grasping things very fast with full concentration. That shows the passion you have for the subject. So density of steel is 7,000 kilogram per meter cube. Density of water is 1,000 kilogram per meter cube. Density of iron is more, right? So if you look at ship is made of iron, which has got a density far higher than density of water. Then how is it floating? Right? The reason why it's floating is the way it is made. If you look at the ship is made of is made in this shape. So you can see that there is lot of part of the ship which is hollow. This is hollow, right? But that much volume of water is displaced.
Water level
So
rises.
yeah, and so the ship is displacing a lot of water because it is made of steel, and this whole part is in fact hollow, right? So gravity is acting downwards, right? Definitely there's weight, so it has to go down really, but it is not going down because the buoyant force is acting upwards, and the Archimedes principle is applying, and the buoyant force, which is equal to the weight of the liquid displaced, and that weight of the liquid displaced is very high in the case of ship. And since that is a huge amount of water which is being displaced, you can see here for container ships, you can see that it's far more volume. The volume of liquid is displaced by container ships. So it's more weight of liquid is displaced, and because of which the buoyant force is very high. So that is because of, but if you start putting lot more weight, at some stage the buoyant force will not be as much as the weight of the ship, then it will just sink, right? So that is what is going on. So again, the ships are floating because of the buoyant force, right? So I hope that understood the principle. Similarly for the boats, right? Anything that you see, you can see the boats floating in water, again because of the buoyancy. So the buoyancy is what is basically helping, and that is the same reason why you feel light in water, again because of buoyancy, right? I hope you understood the Archimedes principle. We did a problem. I gave you a problem for you to do it yourself. Please try to do it. Please learn the derivation of buoyancy, the Archimedes principle, which I did in the last class. If you have any doubts, please get in touch with me. Again, I am giving you the details of my website. Please do visit it. It is http://navayug study.wordpress.com. This is the website. I will actually in fact also show you. I'll visit it and show you. It is here it is. This is a website. http://navayogstudy.wordpress.com. Please go there, and it has got. I have not started putting the eight videos yet. I'll be doing it from this week onwards, so soon that will also be there. Don't worry. This is my website, and you can see for each class you can get all the videos, and if you go to a specific subject, you can see here I have also shared the Dropbox link where all the presentation material, notes, everything is available. You can go and look at that and download it as PDF documents and use it for your reference, right? So these are all the presentations and so on. Sometimes in some cases I will also have notes, right, of that. And just go back. There are also forms for submitting questions, also for requesting the Google Plus sessions with the faculty. Please make use of it, and just visit the website. All right. Okay. Have a great time. See you for the next class. Bye bye. Till then, go through the videos, go through the textbook, revise what I taught you in the class. Send questions to me if you have doubts. Ask for Google Plus sessions. Join the Google Plus community for that we can have discussions. Have fun, guys. See you for the next class. Bye bye.